Video. GC. Video. Learning. Guidance. Community. Gas detectors.
Good morning, guys.
Good morning.
There you go. That's what I like. So, how can we say a portable instrument is also a personal gas detector? Good. Very nice. You're very well briefed. We will be having a familiarization for personal gas detectors. Okay, so do you have any idea how does personal gas detector and portable gas detector differ? This is actually portable. There are a lot of portable instruments we have, but how can we consider something, a portable instrument, being a personal gas instrument, personal detector? Any idea?
Easily to carry.
Easily to carry, that is already portability. So you're just saying it is portable. How about specifically, how can we say a portable instrument is also a personal gas detector?
Personal have alarms.
Good, very nice. You're very well briefed. So if there is alarm indicators, this is actually being considered as a personal gas detector. Okay, understood? So if there is no alarm trigger, you're just bringing it on your own, it is just a portable instrument. So examples of our portable instruments, we also have the Dräger 237H, which is actually an explosimeter, which actually LEL and volume percent is being detected. We also have another one, which is the oxygen analyzer. This is also portable, but it doesn't have any alarms. So it is used for oxygen detection of the content in the particular space. But now, if we are talking about personal detectors, there should be alarms. Understood? Okay. So this one, actually, you've been hearing the buzzing of this. Something like that. So this is actually considered a personal gas detector. This one, Dräger XAM 7000, is our unit to be used for measuring toxicity. Okay? So when you are having a measure of ppm, parts per million, it is measuring the toxicity of a substance. Okay. Do you have any further questions when it comes to personal and portable gas detectors? Anything that you can share?
Oxygen.
Yeah.
H2S.
H2S, yes. We actually have those. We actually have those in our multi-gas detector. So, yes, CO2, actually, mainly CO, carbon monoxide, not CO2. Yeah. So, we have the multi-gas detector, which is a personal gas detector, which has 4 sensors. H2S, carbon monoxide, oxygen content, and DLEL, okay? So, anything else that you want to clarify? So, first, we'll be talking about the toximeter. Toxic meter, toximeter, there are a lot of phrases that you can actually name this one. It's even the unit itself, Dräger XAM 7000. Okay, so we have 2 units of toximeter. So how can we say, or how do we gauge a particular thing? Do you hear about this TLV, threshold limit values? You've heard of this? Okay, now TLV is actually...
Better explain.
Yes.
Better explain what is this TLV,
Yeah.
TWA,
Yes.
the steel, steel.
Sure.
Yeah,
Okay.
explain to the
For the
what
info
is
of
this?
everybody, what is TLV? It's actually the threshold limit value. Now this is actually divided again. There is actually what you call TWA and STEL. Okay. So for this one, actually it's not ready, but for example, time-weighted average. You can actually see particular MSDS where it mentions TLV, TWA. There's also another one which is a TLV, STEL, or maybe no mention of those, but it is indicating 8 hours or 15 minutes. Now, we try to break it out. So when you say TLV, time-weighted average, so TLV, TWA, it is the maximum exposure on a particular substance or gas, whatever, in a particular ppm that you are safe to work continuously for 8 hours. Okay? So meaning, if you are exposed to this particular reading, for example, you are having a readout of 200, 300, we actually have a table, which is this one. Okay? So, from the data sheet, you can actually see it is actually a larger value. In the data sheet, we have 500 ppm. and it is mentioning within 8 hours. So meaning, if you are having a readout here of 500 ppm or higher, this is actually not permissible for work within 8 hours. You understand? So again, if you are having a reading lesser than 500 as per the safety data sheet, then you are still able to work continuously and it's fine for this exposure. Okay? You have a limit of until 500, and beyond that, it's actually unsafe for you. So in this exposure of 500, you actually have 8 hours continuous work. You can do that. That is for TLV, TWA, time weighted average. Now, we have the TLV, STEL, short term exposure limit. So this is just 15 minutes. This is actually higher values. Now, if you actually see, what is our cargo? Propylene. So you can actually see here, propylene all the way. We actually have something coming from the United Kingdom HSE, so Health, Safety and Environment Department of theirs. This is actually the reference. So we have, for example, the propylene as a general guidelines. We have it as 100 for the TWA and not applicable for the STL. So you can work entire day straight for 8 hours until 100 ppm. Now, it so happened BWEC is actually using a factor which is 50% of the OEL. This is the main OEL, 100, but BWEC wants to make sure. So rather than going for that 100 for the TWA in here, we actually only gonna do we actually have until 1% of the LEL, which corresponds to 200 ppm. Okay, in the data sheet it is mentioning 500, but here we are mentioning 200. We will be following the most stringent one, and that is from here, the smaller value. Okay, so most of the time in our practice here, while we are employed in BWEC, we will be following this table. Otherwise, if there is no info, then we go to the safety data sheets. Understood?
Yes, sir.
Okay. Now we will be mentioning about the so you already know the purpose of this, the toxic meter. Any other questions for this one? Okay? Alright. Now, any questions? So this is clear, TWA and STL. This is clear, okay? So STL is only up to 15 minutes. Nothing beyond that. Okay? Only 15 minutes. So you can actually be exposed way higher, 5 ppm, 3 ppm. But for example, for the propylene, it's just the same, 200 ppm. 15 minutes or 8 hours, better we go to the 15 minutes or not be exposed at all. Okay? So this actually has a readout. You can see here. Here, you can actually look. This is a very large digit. It's mentioning 0. And this is actually measured in ppm, parts per million. Okay? Now, we will be doing the calibration of this one. So, the calibration is actually to ensure that the instrument is working properly. And as per this standardization, the office is requiring us. So, we are actually having also a program of this for 3 monthly calibration. So remember, every 3 months, we should be calibrating the personal detectors. Okay. So how do we calibrate? We have one program here. This is the toxic meter, which is in this computer. The other one, the one you are using, the multi-gas detector, the red ones, will be calibrated on the other side. This is because of the availability of the computer ports. It is activated here, but not there. Something like that, okay? So the installation issues. So this starts in the desktop. You see this CC Vision Basic. So this is the program for calibration. Okay. Now, if you double click on that one, this will how it look like. Then this is actually should be turned off when you're about to start. This will have a difficulty to detect if this is already turned on. Okay, but we can try for you to be sure. So when you turn on, just long press this color green, and when you want to turn it off, long press 2 buttons. Okay, there will be a countdown. 3, 2, 1. It will buzz. Okay. Now, it is not advisable to have this turned on and then you're already in the program. Okay? Can you get the other unit, please? Yeah. The other unit. Yeah. Yeah.
That's all.
So the setup here, we actually have, this is actually the charging dock. But a multi-purpose dock also where you can also do the calibration. This is where you connect for the USB and into this Dräger. This is actually Dräger. It actually stands for a particular acronym, but it's actually more on NME stuff, communication stuff, something like that. So just have this one. It actually has a rectangular thing, so USB, DIRA, and then you just put it like this. Okay. So there's actually a blank space, and then the one with the font, put it like that, and then you put the unit. Okay. So this is actually being transmitted through infrared. Okay. So this one also has it, infrared below, but because of this reflector, it can go to transfer here. Okay. Put that one, and you put this one. Okay. So sometimes when you are putting the unit, it actually goes to charge mode. So when you see there is actually something like a 96%, so it is actually indicating it is charging. So press again. Press again by turning on again. How you turned on, color green button, you will do it again, okay? Ensure that the timer runs. There is a timer here, you can see? There's a timer, okay? Timer. Okay? With the timer running, you can actually go already as per the instruction. The program, this will open. Then look for receive data from XAM 7000 because that is our unit. Correct. XAM 7000. Press this one. You will actually see here, if you can see, it will turn into PC mode. You can actually read here PC mode. Yeah, you can come. Go. Okay. So ensure there is actually a reflection of PC mode, personal computer, PC mode, and then this will appear. Okay, are we following? Yes. Sure. Huh? Okay. So normally for this unit, there is no requirement for bump test. Directly for calibration, you can go ahead as per the makers. Okay. Now, we actually have 3 calibration necessary for this one. So we have the fresh air, the zero, and the span calibration. Okay? So the purpose of this fresh air calibration, you want to calibrate it in fresh air. Unfortunately, this isn't that fresh, but this is actually tolerable. Next will be the zero calibration, so it will detect and put back any errors of values into zero. And then span calibration is when we introduce already the span gas. So the purpose of the span calibration is that it will be using a particular span gas, and it should actually meet, as per here in the bottle, it says 100 ppm. So if there is actually deviation of readouts, normally you are reading 120 or 130. In the span calibration, it will automatically correct to compensate it as 100 ppm. So again, the gas composition necessary, we are already also labeling it for everybody's convenience. But for the composition, is actually isobutylene of 100 ppm with air balance. If you are not so sure as to what will be the bottle or what will be the span gas to be used, we actually have a list for this one. Okay? So the list will be shown to you later on. But for the moment, we have this. We have labeled for your convenience. Proceeding on the calibration. So we will be doing fresh air calibration first. Fresh air to have the instrument ready for the actual fresh air. So that in the zero calibration, there will be no issues of deviation of readouts. Now, in fresh air, there is no need to attach the span gas. Okay? Just let it be as is. Just put this instrument and then we go to fresh air calibration. Ensure this is selected. PID. And then you can already start. Again, fresh air calibration. This is actually hidden at the very first place. So click the plus. Fresh air calibration. Ensure it is selected with a check mark and then start. It will tell you later on that the signal is stable, you can perform the calibration. So at the moment, just leave it like this. And it's actually reading already. Now you can actually see if your readout is actually stable. Here you have. You see this is running violet. Can you see that one? Can you see? As you can see, it is already stable, right? You can actually select apply. Click apply. And by the time you click apply, at the moment this is gray, right? When you click apply, this will have color already. The signal is stable, you can perform the calibration. Okay? Again, try to check if it is stable. Go to apply, signal stable, perform calibration. You click this one. And you are done with the fresh air calibration. Just click OK. That's all for the fresh air calibration. For the zero calibration, so we'll be doing the zero calibration now. So on the same one, calibration sensors, you have the options. Go to zero calibration. The same goes for this one, like the fresh air calibration. Click the PID and then start. Again, since this is just zeroing, no need to put any span gas. Then start. It will say supply gas to sensor. It is actually mentioning about air. So there is no necessity for a span gas. No, because we are trying to have it in zero. So fresh air alone, you can go okay. And it should measure always zero most of the time. If not, it will have a readout. Then it will automatically correct it for later. Okay? This is just newly calibrated last April 29, so we are not expecting any much deviations. Now you can see, is it already okay? It's stable, right? Okay, now in zero. So you can click, apply. So as again, it is still grade. When you click apply, you can already click this one. Click it. It will mention to remove the gas. So again, we did not put any gas because this is just zeroing. Again, fresh air and zero calibrations, no attachments of span gas. Okay? Then okay again. Then you have a choice there. You can actually see after calibration, it is already zeroed. Okay? So are we understood with the fresh air and zero calibration that the span gas will not be attached? Okay? Okay, that's good. Then the last will be the span calibration. Now, we actually have this. The other one, the other plate, you can see, we actually attach it already here, something like this. It actually has 2 ports, correct? Now, you can actually see we also have another one which is only 1 port. So, make sure these 2 ports is actually to be used for calibration. 1, 2 ports. This is the inlet. Always the inlet is the middle one. And this will be the outlet. Now, the other one, the other plate that you can attach is actually used for measuring. Again, this is for calibration. And this is for measurement. Actual measurements. Now, why is that? Because most of the time when we are actually trying to measure a particular object, a particular vapor, we're actually doing it in a very low pressure. Sometimes it won't go through the pump. Now, these sensors have a built-in pump, which can only be activated by this magnet. So, the pump will run if it senses the magnet. What you can see in the other one, there is nothing. Can you see the difference? This is actually just blank. The other one has magnet. See? Can it be seen clearly? Okay. So the one with the magnet will be using for activating the pump and will be used for measurement. Understood?
Yes.
So we will not be using this one because we're gonna calibrate, because we already have a forced pressure in here and then going out. Okay? Now, we will be attaching this into the front. You see these two holes? This one, you can see? Can you see this? Everybody. This can be seen. This is actually two screws, correct? Here. So you attach this one to those holes. Okay? Fix it. Have it snug tight. And then later on we'll be attaching this to this fan gas. Okay? So you are in this window, click PID. No need to check anything here, and then you click start. You'll be told to supply the gas to the sensor. Connect it, then open the valve, then click OK. So the readout should rise all the way to the set value, which is 100, which is also reflecting the same on the span gas button. So now it is reading out 12 all the way. Now 74, 80, 84. That value corresponds to the graph and also corresponds here. Okay? So just wait for the instrument to become stable. The readout. Okay? As you can see, you cannot actually click apply if it is not stable at all. So now it became white. Earlier it was actually grayed out. Okay? Just observe. Yeah, still rising. See, this is grayed out, correct? We cannot click. Okay? So it would not let you apply if this is not even stable at the very first place. Now we are in 100. So if you find that the readout is already stable, you can also be able to click apply. So we can already see, is it stable?
Yes, 100.
Okay, now we can already click apply. So this is newly calibrated, so it's actually meeting the main values. And then, signal stable, perform calibration. Remove the gas. Okay. Then, that's about it. Yeah. Instrument can be removed. And then, you can actually get the certification of this one through the calibration history. Go to the calibration history. There is actually here print all. So when you actually print, you're only printing the recent operation you did, and that this is the span calibration. But if you select print all, the three, fresh air, zero, and span calibration will be printed out. So we go print all. There, you can actually see the fresh air, the zero calibration, and also the span calibration. So result is okay. Okay, okay. So, is it understood? Okay. This is a multi-gas detector. What was that on the other side? Toximeter, toxic meter, something like that. This is a multi-gas detector. Okay, why multi-gas? Multiple gases. What are the gases being detected? You can actually see. Okay, very good. Now the question is, do you know the differences of those? Okay. What are the properties or the characteristics of those? Oxygen, that's a given. You already know what's oxygen. Let's proceed with carbon monoxide, CO. What, do you have any idea what is carbon monoxide? Carbon monoxide, engineers. Exhaust, where can it be released? Anything else? CO. Carbon monoxide. The one we are breathing out, is it CO?
CO2.
CO2. So it's dioxide. Good, very good. So carbon monoxide, what else? So exhaust, emissions, all of those stuffs. Okay? Now we will be going for ethylene. Now here's the take in here. There is a cross sensitivity between ethylene and carbon monoxide. Now, how can we detect, because of the cross sensitivity, if ever we'll be carrying the ethylene, how can we know that a particular readout of carbon monoxide is legitimately carbon monoxide, not the hydrocarbon? Again, it will not display as a CH4 or any LEL content. No, it will reflect as a carbon monoxide. Ethylene, huh?
Yes.
Now, how can we detect? So we will be using tubes. Okay? So, in the event that you are actually getting a readout of carbon monoxide, but you are subjecting to yourself or you are in doubt, maybe this is ethylene. You are using these benzene tubes, correct?
Yes, yes, yes.
Similarly, we have the carbon monoxide tubes. Okay? So we will be using that carbon monoxide tube for the actual detection of carbon monoxide. Understood? When carrying ethylene, cross sensitivity on the sensors in here, it will display as carbon monoxide. In order for you to have the verdict that it is legitimately carbon monoxide, you will be using the gas tube of carbon monoxide. Okay? And by the time you are trying to detect it with the tube, and there is no carbon monoxide readout on the tube, but it is reflecting here, it means it is ethylene. Understood? Okay. H2S, how do you define H2S? Hydrogen sulfide. So, do you have any background or any actual experiences to H2S? Bunker. This is actually like a rotten egg, okay? But in certain threshold, it will actually numb your senses to the extent that you are not actually smelling it anymore. And you are actually trying to think, it's just fine, it's becoming okay. But actually, it's already dulling your senses. So be precautious on this H2S. Okay? Any other emissions of the H2S? Where can we have this? In the paint lacquer, is there an existence of H2S there? Yes, possibly there is. Okay? How about, so we have another one which is the %LEL, lower explosive limit. Mostly that is the hydrocarbon, the cargo itself, other than ethylene. Okay? So propylene, if we have actually a readout for that, it will actually reflect in here. Okay? %LEL, like that. Okay? But the best to measure propylene is through that one, the toxic meter. That is the most advisable to use for this cargo. Okay, this one, this is just your personal, you're gonna be using so that any deviations or it can trigger actually alarms for you. Okay, so what are the alarm settings in here? So alarm settings, you can see alarm settings. Okay, okay. So there is alarm 1 and alarm 2, level 1 and level 2. You can see. So how does it indicate for level 1 and level 2? So normally level 1, you can see hydrogen sulfide, carbon monoxide, hydrocarbon. Usually what is being made here is actually for the reference also of the TLV. Actually, in reference to the TLV table. Okay? The one I showed you. Okay, now for the first alarm, it is actually a pre-alarm. The difference of the second alarm is actually a continuous one. So alarm 1, it will be like something like that, intermittent. But if it is something like that, continuous, there is the second alarm, okay? Pre-warning alarm, alarm number 1, you should already be evacuating. And then the second alarm, there should be no total work during that time. The exposure to that is way, way high already for human exposure, normal exposure, okay? So when you're already hearing number 1, alarm number 1, you can already slack off and then take out. Get out of the vicinity, okay? Save life. Before the usage of this one, every time, okay? This is actually applicable to everybody, okay? I know you are bunkering, we are doing gas operations, gas cargo, blah, blah, blah. When it comes to the very first time you're gonna use this one, always hold air calibration. Always air calibrate this unit. Do not ever use this when you just took it out from the charging dock. Always use air calibration. How to do it? Long press air. You have it here, air, right? So to turn on the unit at the very first place, you have this one. Turn on and turn off the power. So this is already turned on now. So when you turn off, long press to the power, it will say release later. Okay. The same goes for the turning on. Long press. When you have the readouts here, you can actually release. It will actually show later on for the alarm. There, alarm. Actually, it's just a very fast showing, but it is reflecting the same on the table. So, how to air calibrate? Prior usage. Again, prior every usage. Air calibrate, long press. It will mention release. Then release your finger. Okay, now this is ready for use. But I highly suggest doing the air calibration on the actual atmosphere outside, not here. Okay? So for the sake of demonstration, I did that here. Okay? But actually, when you took it out of the charging dock, get outside, press air calibration before you go to the vicinity of work. Understood? Okay. Now, we'll be doing the calibration, which is also 3 monthly, quarterly. So we do the calibration for this one. But unlike the other unit, we'll be doing also bump test. So what's the purpose of the bump test? Any idea? What is bump test for? We are doing calibration. Span calibration is just similar words. But when you say bump test, you are actually testing the effectivity, efficiency, or if the sensors are really working as how it is normally. If the bump test fails, there is no point going to the calibration because maybe there is something wrong in the sensor. Okay? So again, bump test first. So you will know that the sensors are actually detecting properly or are in good condition before the calibration itself. Any questions before we proceed? Okay. Which stands for single duct module. Singular duct module. Okay. Turn on the unit. Now, later on, we'll be turning off this. So this should be turned on when the duct, when it is attached in the duct. Okay. So we turn off again the units, please. Anyway. So again, we turned off. This is ready for attachment later. So how do you attach? You slide the sensor side and then push. Can everybody see? Come, don't be shy. Again, you attach this like this, okay? Push the sensor side, then push the unit itself. Okay? How is the data being transmitted? Same with the 7000 by data transfer through infrared. Infrared, okay? You see? Okay, infrared again. So when it is attached, the infrareds are actually meeting each other. Okay. Now, The program for this one is different. So the program in the previous is actually, what's the name?
CC.
CC Vision. Okay. Now here we actually have this one. SDM. Have you seen this icon? SDM. It's actually also the same in here. SDM. SDM GX docking. It actually has a longer name. But just get this one. This is the icon. Again, SD. Then you turn on the detector. Long press. Now you can see transmit. Any inactivity of 20 seconds will make this turn off again. So immediately we proceed. Now, you can actually hear connected with docking module. This is the unit. You see this is grade. This is actually the active one. The one in here.
So 3.
Yes. You will be waiting for this one. Parameter reading completed. Parameter reading unit completed. You see, it actually went from here. It is connected, but that is not yet. Wait that the parameter readings of the unit is completed. You can see here, bump test and calibration, correct?
Yes.
Okay. Since we usually do the air calibration here, there is no need for that. You can go directly for the bump test and the calibration. Make sure you click the unit and then prepare for the gas. Now, the bottle for this one is this. It's actually having a marking already, GX2009, but to be sure, since it is multi-gas, we have the H2S, we have the carbon monoxide, we have the oxygen also, and nitrogen mix, and also the hydrocarbon. So again, hydrogen sulfide 25 ppm, carbon monoxide 50 ppm, the cargo isobutane is 0.9%, oxygen 12%. So we are expecting on the termination of the calibration, we'll be meeting the parameters of this one. You see? Okay? So again, for your convenience, we are marking it already here, GX 2009. Okay? See? Okay. Now if you can see, this one, this regulator is different compared to the one we used there. Now this is a demand regulator. You need a pump drawing for it to release the vapor. Unlike that one, you will just have to open and pressure will be coming out. In here, the pressure is locked until this draws the gas. So there's also a pump in here. Okay? So I repeat, this is a demand regulator. Okay? There is no need for you to use the other one. Okay? Because at the end of the day, you don't want to damage also the sensor of this. The pressure regulation there on that particular regulator is actually too much to handle for this one. So whatever is just needed by the pump, this can do the job. Okay? You see? Can you get the other regulator, please? Just to differentiate. You can actually see this is actually having a bigger head. Yeah? Okay. So we'll be attaching this to the bottom. But be cautious. You have a standby unit because this will actually continuously release at some point. Okay? Oops. Okay. So ensure you have enough pressure, okay? Alright. So actually now it actually reflects here. There is actually a content. So this one.
Pressure showing?
Now it's around 500. Now 500.
500 bars.
No, it is about PSI. 500 PSI. So you can actually see here there are a lot of ports in this one. See? So this is for the USB going in here. This is the power outlet 12 VDC direct current. And then air and gas. For the air, just like what we did in the 7000, no attachment. Okay?
Just push.
Just fresh air. Leave it as is. For the gas, so we'll be attaching the end of this hose in here. Gas, okay? See? Calibration gas in here. Now we can actually put, anyhow, it's just a demand. Okay? Now we can proceed. Make sure there is a word of transmit. Okay? So it's still transmitting, okay?
At the bottom.
It means there is still the active transmission between the computer and this one. So, what have we attached? The USB port, the power supply, the gas supply, leave the air supply as is. We following?
Yes, sir.
You back? You okay? Alright. Now, we proceed. Kindly please do the bump test first. So you have selected already the unit. Click bump test. Make sure everything is checked and then click OK. OK again. Here. Bump test. OK. Air is flowing. So, air is already being drawn to the unit. This is actually easier compared to the other one. You just have to attach, click bump test. If it's okay, go to calibrate. That's okay.
What is bump test? What is bump test?
Are you here during the discussion? What is bump test? Anybody?
So check the efficiency of the detector.
Yes, there you go.
$5.
No.
$5.
So, air is flowing, just like bump failed, then it is color red. Which means the sensors are working fine. So, we click OK. Click this. Okay, now we can actually proceed directly to calibration, but wait first.
Auto power off.
Yeah, wait. Yeah, auto power off because there is inactivity already, as what I've said. So, make sure to also check here. Turn on again.
But when this is completed, the calibration is completed, the pump will be automatically off also.
Yeah. So now you have the transmit. So wait again. As what I've said, previously it was connected also, but wait for the completed. The one with the word completed, okay? Now completed. Now we click this one. This is actually the active unit. You can see there's actually no numbers on the other ones. This is the active. Then you can go to calibration directly.
Calibration.
Make sure everything is checked, just like the bump test. Okay.
Okay.
Click OK again. It will say calibration. Okay. So this is really easier compared to the other one. Okay. So do you have any further questions? So what we did, air calibration, bump test, and also the span calibration. Okay. Do you have any clarification? So you also know the difference also of the personal detectors and just a portable detector, correct? How does it differ?
Have alarm. Personal.
Have alarm. There you go. Very nice. So we're really learning a lot, huh?
We don't have to adjust the regulator for this one, sir.
This one, no need. There's actually no option for that.
Only demand.
Yes,
You have
only
to-
demand.
There will be
Yeah.
gas release whenever you disconnect.
Yes, there will be a tendency. Okay? So do not forget, we always have a permit when we are doing calibration of these detectors. Okay? So we're just waiting for the result. Hopefully it becomes pass or green. Okay?
Pass.
So this is fairly easier compared to the other one. Correct? Okay. So anybody can actually do it. Yeah.
Thank you very much.
Thank you very much for your cooperation. Have a nice day.
In this video, we saw several gas analyzers, understood their differences, and learned how to calibrate the devices correctly. Remember that a gas leak on a gas carrier is dangerous for your life. Thanks for watching the video. See you next learning.